Welcome to a new test and teardown video. This time we're going to look at a Wavetek voltage controlled generator VCG model 111. I believe this one is from about 1965. At least this is what is written on the different schematics. It was quite easy to Google to find the full service manual, and it explains exactly how this thing works. And I think it is very interesting for a product that was made in 1965, full of transistors and a few ICs. So it's top modern for its time, and it's quite compact, as you can see here. Unfortunately, this unit is not working, so I need to open it, inspect, and see if I can find the problem. We got a few little details here about the front. Look at the 6 BNC connectors. So all those outputs there are active at the same time. Of course, it's the same frequency, but different waveform. And here there's also an output driver where you can select the amplitude and wave shape and all that kind of stuff. So that is here. And all the other outputs there are low power drive. The frequency dial is a 1 to 10. And there is a power on switch and range selector. So it's ×3 or ×1, and then we got 8 frequency bands, and look at that, 0.01, really? So this is 10 millihertz. Amazing. And there's a nice handle here on the back, so you can easily carry this thing around. And a 1/4 of an amp fuse. How lovely is that? Mains transformer is obviously right there. And yeah, this is clearly nice and old. I kind of like the position of the handle, because if you put it here on the top, I mean, you can't stack units on your workbench. So this is nice. And also all the knobs, they are this sandblasted look, except for one. And this one is obviously not the original knob. So that was lost somehow and then replaced with another funny. Maybe it's because this switch is a little bit tight to move. And then somebody thought, hey, let's upgrade this unit by adding a bigger knob, because you can imagine a tiny little knob like this, and then this, quite difficult. But how about just fix this so it's not so difficult to move then? This looks really bad. So my idea is, if I can get this thing up and running, probably replace it with another switch or another knob like this. I try to find in my little knob drawer. I went for the same diameter and height more or less, but I like this one the most. At least it's better than this one, right? Maybe I could also make it sandblasted look instead of this shiny look, because it's not really fitting together with these. So if I could probably get this sandblasted, then it would be real nice, right? So let's have a little look on the inside. It is very, very nice and compact designed. Try and look at all that. So we got the 3 plug-in boards and the front panel board. You can't really remove the front panel board or the motherboard, sort of speak, or backplane board. But if you want to lift out any of these plug-in boards, you need to remove the shaft that goes to the power on off. That is neatly located here at the back near the transformer and all that high voltage dangerous stuff. And it's also the range switch. I was able to lubricate all the switches and now they move nice and fine. So far so good. And I haven't found anything visual that will prevent me from powering this up. Both fuses, they're intact. And I don't see any cracked or leaked capacitors. So I should definitely be able to power this up. I've been inspecting the schematic a little bit. And the last module here is a power supply and the output amplifier. And I should be able to measure the power supplies plus minus 25 and plus minus 6 volts. And fix that unit first if that is not present. That is what I want to go for. I also looked a little bit on the signal generator and the voltage control system here. And it looks like I don't have the current version or something. Because if you look into the boards, all you see is transistors. See, we got some thermally matched. Oh, is that totally out of focus? Look at that. But I don't see any ICs. And there were supposed to be at least 2 or 3 integrated circuits. But I don't see them so far. Maybe they will show up. Let's see if I can get a picture on that. Where I want you to look is, see the interconnects here from the bottom panel to the front, and there's a screw here, right? Let's see if I can get this into focus. I don't know if we can pull this off. Hang on, let's get some light and you will see what I'm talking about. Yes, here we go. That screw is touching that pin, and it is exactly the same problem in the other side. Ooh, we need new glasses. So that is probably one of the problems. I will try and unscrew these 2 screws first, and then power it up. As always, I want you to be a part of the power up. Power is applied and current consumption is 0.0. Okay, that is interesting. I did not expect that. Okay, fuses are okay. And my power consumption is 0.0. So it may sound a little bit crazy to look at this, but when you see a wire that is a little bit loose, then I want to go and inspect a little bit here. Is it really possible? I think we can have a little laugh together, but I think I probably found the problem. What happened here? How is this possible? But clearly not made correctly. But how is it possible not to have a contact? Maybe that one? Yeah, I will try and redo this the proper way, and let's see if it's working. So I called in some professional help to make this little repair. So here we go. Let's try again and see if it works. And we got output. So, thank you very much to my daughter for solving the big mystery about the mains connector. That looks nice and fine. I was a little bit skeptical about the sine wave converter, because this one is a ramp up, ramp down kind of oscillator, and the sine wave is generated, yeah, using a sine wave generator from that sawtooth. And I don't know if you can see that, but the sine wave look a little bit flat topped. So I think I will go and get my harmonic distortion analyzer. Times 3. This is times, there is a dot, so it's 0.3. Oh man, that is me who is absolutely not looking carefully enough. So that is what it is, times 1 and times .3. Okay, that explains it. So it's not going that fast anyway. And it can, so that is, that is nasty. So that is the full speed, 400 kilohertz, and it is not looking pretty. And then it goes quite nice at, yeah, okay. See, there's a little dot up there. That is obviously the ramp start stop. Let's look at the variable output. Here we go. This is the variable output. Oh, that potentiometer needs a little bit of contact. 61, huh? But other than that, I think we could call this unit fixed. And the frequency is 92 kilohertz instead of 100. And in 9.5, so it's not super bad. Let's go in the middle. 47. It should have been 50, right? So it's not completely bad. What is the power consumption? It is only 6 watts. So that's quite nice. I think I found a problem. See? The potentiometer for frequency setting. Wait. So this is the lowest part of the range. Let's just go all the way to 1 here. And let's zoom in a little bit. I don't know if this is visible on the video, but this is just moving completely unstable, and it is down here in the low. If I crank it up, see, it is nice and stable. So it isn't this range here, and then so if you want to make 1 kilohertz, this is not how you do it. You want to go to the previous range and then crank up the frequency to 10. And now it's nice and stable. That is really, really weird. But if I am in this range and go down to the lowest, it's not unstable. So there's something with the 1K range and in the lowest setting. That is weird. If I go to the 10K range, it is also not really there. Aha. So that is something. I maybe should clean this a little bit more. Or massage this probably a little bit more. Maybe there's something. I also tried to move the boards, and I don't see that I'm able to create any kind of unstable behavior even from mechanical. Oh, they're not that warm. If we look inside this unit a little bit deeper, yeah, to get all the plug-in modules out, of course, like I said, you need to unscrew the two set screws here and then pull out the shaft, but don't pull it out all the way, because this little indicator thing is going to fall down. See, this little shiny indicator here, see? This one is going to fall down and get lost, and it's going to be tricky to get back again, right? So this is a very, very beautiful unit, and I believe this, what I got here is the old version. It is the all transistor version. It's quite well made. To be honest, I am a little bit impressed. But Wavetek, yeah, they kind of always impress us a little bit when it comes to the design and mechanical integration and all that kind of stuff. It's definitely how it is. The fun thing is my manual. Maybe I should show you a picture of the manual where you can see the different plug-in modules and the names of the three modules. So we got a power supply, we got the voltage controlled generator, and then we got the main board. So the fun thing is, if we start to look at the voltage controlled generator, if we look carefully on this board here, we can see the picture they showed in the manual. We can recognize the trimmer and that capacitor, and we can actually prove that this is the board that is shown in the manual on that picture, right? So when we scroll down in the manual, there is no information about this board at all. Only the new version of that board, and that is using ICs, much more modern looking design. I should probably put in a schematic of the new voltage control board. And it's funny they don't say anything about this is the new version, and if you have the old version, sorry about that, then you don't have any information in this manual. I mean, that is a little bit annoying. So this is the old version. It's all transistors, and yeah, I don't have a schematic for this one. I kind of like the way the transistors, they are matched, thermal matched like this, and of course it is to create stability and all that kind of stuff. If we look at the power supply board, this is the power supply board. There is definitely in the manual. We'll find component placement. We'll find yeah, everything there is to know about the power supply and output amplifier. And that is a quite nice board. I was thinking about probably trying to replace those capacitors and see if my unstable behavior could be a little bit better. But the thing is that I kind of recognize this brand of capacitors, and I really never seen them fail. So I'll probably try and take out a few of these and measure them. But I don't think that is the problem. But sometimes it is fun to replace capacitors and then just see what happens. It's almost always an improvement. But there's a little fun thing about this design I want to show you anyway. So you see rectifier, there's a bridge rectifier here, and there's a bridge rectifier down here, right? And all the four capacitors, they're located neatly in this area. So AC comes in here, and it goes to the bridge rectifier. So the positive to the output drive goes here directly from the top of the diodes, and then this long thin wire goes all the way to that capacitor here. This is the positive capacitor, and that is the center point of the capacitors. That is the negative side. It is exactly the same all this long track. And then we take signals from here, and we also take signals from here along the track. And this is, as a designer, not how you would do it. You would have the bridge go directly to your capacitors, and then you will take your supply from that the point of the capacitors. This is the cleanest point, and you want to avoid all this coupling like that. This is, of course, not how you want to do it. Here is the main board, and this is the current version. This is the version that is in the manual. I added a little text here so it's easier for me and myself and everybody else in the future to figure out what is what here. So yeah, main board consists of the integrator, because this is a ramp up, ramp down kind of oscillator. And then there is a sine converter. All this is a sine wave converter, and it works using those diodes, transistors, and currents that goes into it's actually switching on and off here and charging, discharging, and this way transforming your sawtooth into a sine wave. And this is working on a very broad frequency range. It's quite amazing they done it that way, by the way. And again, we got some thermally matched transistors. Yeah, germanium transistor diodes, and a lot of field effect transistors and stuff in sockets. Yeah, quite nice. And layout is obviously done manually. This is before you had computer CAD design. So changing the old capacitors to new modern types. Obviously they don't fit super good mechanically, but this old one here is about 1 ohm series resistance, and the new modern one there are 200 milliohms internal resistance. So, but I don't think 1 ohm is defect in any way really. I still measure the 100 microfarads at 1 kilohertz, but I kind of just like to try and put in some new ones on the supply rails and see if that is having any positive effect. So that will be the old capacitor. It's supposed to be 2000. And remember, this is from 1965 or something like that, right? And this is the 1 kilohertz measurement. So it's 0.1 ohm, right? So let's just take a modern capacitor. And you see the value is a little bit higher, but the series resistance, that is definitely a lot lower. And again, I don't believe this is too bad when it's 0.1 ohm. That one is absolutely not completely defect, but when I desolder it, I really smelled a lot of this capacitor leak, smelly. So that is weird. So it's probably coming from the end somehow. And I can also see that we got a little bit of, see that? Right here on the circuit board. So maybe, but I'm gonna go and measure the others as well. So I changed all the capacitors in the power supply. As you can see here, they are a little bit smaller and easier to mount. I added a tiny little drop of glue on these two. But I don't expect this to create a revolution. But I did cut the 2 tracks here, and now I am feeding the current to and from the capacitors correctly, because I didn't really like that. So let's see if this will solve all the problems, but I don't expect it. But anyway. Now what do you know? Didn't I say I didn't expect this to be the miracle? But it is. Look how stable it is. And this is 1 and this is 1K. What the heck? And look. It is completely stable. The problem is gone. I think I can see a tiny little bit here. it's probably a little mechanical. So it is nice and fine. I'm super happy about that now. So now I only have to poke around with this little knob here and see if I can make this not so shiny, or maybe I'll just live with this. Ooh, see? This unstable behavior is that one. So this potentiometer I need to clean. See? It's completely broken. Yeah, let's try and clean that. So that turned out quite alright. I couldn't find a hole into that potentiometer, so I couldn't flush in some cleaning fluid or chemicals in that one. So what I've done is I just massaged it hundreds of times, and it is definitely getting better and better all the time, but you still see some of these little nasty... it's all about either changing that potentiometer or massaging it. And it turned out quite alright with this other knob here. It looks a lot like the same kind of design, right? But next time I go visit somebody with a sand blaster, I could probably add a little bit of sand blasting here on the top, and then it would be super nice again.